Hi there, welcome to Learning Target 15 Day 2. We are talking about dependent versus independent variables. So the essential question for the day is, what is the difference between the two? So that's conveniently located right below. Our independent variable is the x value, and it stands alone. It determines the other value. So what that means is if there is a variable and one of them is dependent on the other, the dependent one is obviously going to be the dependent variable. So independent is x, dependent is y. Time is always independent. I want you to remember that as we go along. Now I want to talk about different ways to describe the rate of change. There are three different ways we can describe the rate of change. We can describe it as positive, so the line is rising from the left to the right, so both values are increasing. It's going to look like the blue line right here. So both values are increasing as you go from left to right. Negative is going to look like the opposite, like this red line here. The line falls from the left to the right, so the independent value increases while the dependent value decreases. So if you were to look, if this was on a graph, so as we go from left to right, we notice that our dependent value is decreasing this way, and our independent value is increasing. Another thing we can find out is if our line is horizontal, it is 0, so it'll look like this. So that means x is changing all the time, but y does not change at all. So in this, we want to identify the different steps we're going to take to decide if our variables are dependent or independent. So in order to determine which variable is dependent and which is independent, you have to do that and then find the rate of change. So our first step, does A depend on B or does B depend on A? So we want to figure out which variable depends on the other. So we're going to take a skip down here and check out this first problem right here. So letter A says 2 pounds of apples cost $3 and 6 pounds of apples cost $9. So in this problem, the number of pounds is affecting how much the cost is. So A and B, so we have B depends on A for this problem specifically. So let's reveal the second step. Whichever makes sense, the second listed is independent and the first listed is dependent. So we have that B depends on A, so A is independent. And B is dependent. Our third step here is to write it as the change in Y over the change in X. So as we saw from our steps earlier, independent, the variable that's attached with that is X, and dependent, the variable that's attached to that is Y. So in this problem specifically, what I want to do is create a chart. So we have X on the left and Y on the right. So when X is equal to 2 pounds, Y is equal to $3. When X is equal to 6 pounds, Y is equal to $9. Now I want to take what we learned from yesterday about the rate of change and I want to calculate the rate of change for this as well. So what we do is we find the difference from here to here and the change from here to here. So from 3 to 9 we had a positive 6 increase, and from 2 to 6 we had a positive 4 increase. Now we're going to write this as the change in y over the change in x. So we have 6 over 4. And what this means is for every 4 pounds of apples, it costs $6. So what we have here is for every 4 pounds of apples, it costs $6. Let's try another one here. An airplane ascends to 3,000 feet. Ascends means it's getting bigger. So your airplane is going in the air. So it ascends 3,000 feet in 10 minutes and 4,500 feet in 15 minutes. The first thing that we want to do is figure out our variables. We want to figure out which one is independent and which one is dependent. So if you can think back, all the way back in this, at the start of this lesson, we said that time was always x. So we have x is equal to time, and y is equal to feet. What that means is time is our independent variable, and y is our dependent variable. Now what I like to do is create that chart off to the side. We have x on the left and y on the right. So we ascend 3,000 feet in 10 minutes. So at 10 minutes, we're at 3,000 feet. And in 15 minutes, we're at 4,500 feet. Now what we want to do is find the change between the two. So the change in the y values, we're going up by 1,500. And then on the x values, we are going up by 5. Now we can write it as the change in y over the change in x. So we have 1,500 over 5. And using our simplifying skills, we can see that 5 and 15 have 5 in common. So it's 300 at the top. So what we really have is 300 over 1. But we're not quite done. I want you to tell me when you're working on these what it means in context of the problem. So every minute, so every 1 minute, the plane ascends, so it's going up 300 feet. And moving on to our last example in this part of the video. It says, in January, the Johnson's heating bill was $100. In April, it was $50. Now you're probably wondering, there is only one variable, and that's dollars, but I want to point something else out to you. We're talking about months, so we're talking about January and April. So those are going to correspond with different numbers. So first we want to figure out which one is independent and which one is dependent. So we know that the months are consistent and they don't depend on the heating bill. So we know that our x value is months and our y value is dollars. So again, the X value is independent, and our Y value is dependent. Now we can make our nifty little chart off to the side. We have X and Y. The first month of the year is January. So in January, the heating bill was $100. And then in April, which is the fourth month, it was $50. Now we want to do the same thing. We want to calculate the change in Y and the change in X. The change in Y, we are decreasing by $50. And the change in X, we are adding 3. So now we can write it as the change in Y over the change in X to get negative 50 over 30. And we're not quite done because, again, I want to write it in context of the problem. So we have every 3 months, the heating bill decreases by $50.